Good day, welcome to your Unit 8.4 lesson. I'm going to show you how to calculate the average rate of reaction for a specific part of the reaction and as well the instantaneous rate of reaction at a specific time. So there are two mathematical tools we're going to be using. It's the secant and the tangent. I'm going to show you how to apply that on a graph so you can get the proper information. Now, why do we do this? First of all, it's because that obviously, if you look at a graph doesn't have a straight slope, right? So if you look at a regular reaction rate graph, you would have, for example, so I have time, and I have a quantity, could be a mass, could be a concentration. We're not really sure, it doesn't matter. So I will have, for example, products will be produced and reactants will be used up. And as you can see, my curves are not straight. The reaction at the beginning is very quick, so the slope is very steep. And then as the reaction slows down, well, my slope gets smaller. And the same thing here for the products, it's even more obvious. Here the slope is very steep and the reaction slows down to a stop. So because the reaction is not even in speed, well, we may decide to calculate to observe or evaluate how the reaction occurs. We may decide to evaluate, for example, the speed at this point in time or the speed at this point in time to again see how the reaction progressed. So how do we do this? Let's take a look. We have an example over here. So first point, we'll use the secant if we're looking for the average reaction rate, and we'll use the tangent if we're looking for the instantaneous reaction rate. So how does this work? You have an example here. They gave you the concentration of gas C, and they graphed the whole thing for you. So they're asking you in A, calculate the average reaction rate during the first 5 seconds. So they want the average reaction rate, which means we're going to be using the secant. So that's what they did over here. They showed you the secant from time 0 to time 5, drew the secant, drew the triangle, and then they're going to calculate the average rate of reaction. So at 5 seconds, I have 3 mole per liter of that gas, and at time 0, I have 0 mole per liter of that gas. So if I look at the calculation on the next page, so I'll do delta concentration over delta time. So we said at 5 seconds, the concentration was 3.1 times 10 to the negative 3 mole per liter. That is what the y-axis was indicating, that the concentration was times 10 to the negative 3. So we said at 5 seconds, the concentration was 3.1, and at 0 second, we had no product, so 0 mole per liter. So delta concentration over delta time gives me the rate or the speed of reaction, which is the following. That's pretty easy. Actually, you don't really need to draw the secant. You just pick the points directly on the graph. They wanted between, for the first 5 seconds, so time 0 and time 5 are your limits. So you just read right off the graph what the two concentrations are. What is a touch more complicated is when we want to calculate the instantaneous reaction rate, like here, at 10 seconds. So what we need to do here, they made a mistake, they drew a secant. I redrew the tangent in yellow. Now what you want to do once you drew your tangent in yellow is to do the following. Just give me 5 seconds. Okay, so I want to know what is the concentration at this point and this point. And this is for time 15, and this one here is for time 5. So now I can do my delta concentration over my delta time, and I will obtain the exact rate at 10 seconds. So at time 15, it's about 5.8. At time 5 seconds, about 3.5. So if we look at their calculation, I think they have slightly different readings, but it basically will give you a similar rate. So I would have said personally that this is 5.8 8, and this is 3.5. The time, delta t, 15 and 5, that is fine. So that gives you the same answer as they get, which is 2.3 times 10 to the negative 4 mole per liter second, which really shows you that it doesn't matter at what angle you draw your secant, your tangent, sorry. It doesn't matter at what angle you draw your tangent, as long as it's not crossing the curve, it's just sitting on it, so to speak. You should get about the right answer or the same answer. We will accept, no matter what, a slight variation on a test, for example, so you don't have to be stressed about that. So that's the way it works. That's pretty well it for that. See you next time for another lesson. Bye.